one of the most fundamentally important concepts or topics in statistics is the z-score. The z-score. Now, the z-score, simply put, is a unit of measurement. It's actually the number of standard deviations a value is away from the mean of the data set. So let's say, for example, we have some data set, I don't know, it doesn't matter really what it is, it has a mean of 10. And let's say the mean of this data set is 10 and the standard deviation is 3. In this video, I'm not going to talk about calculating the standard deviations or the mean. Let's just assume we already have these numbers. And let's say we have an x value and another data value, and that data value is 16. And we have another data value, and that data value is 7. Well, if we look at 16 on the number line, let's say it's maybe right about there, and we could put the 7 on the number line, maybe right about there. Now, how far apart are these numbers? Well, from 10 to 16, that's 6 units. So 16 is up 6 from the 10, or positive 6 units from the 10. Let's use blue for that one. So the distance between the 16 and the 10 is plus 6. And the distance between the 10 and the 7, well, it's down 3. So let's say it's a negative 3. So rather than measuring this distance as in individual units, we could measure it in something else. Just like we could measure something in feet or miles or inches or millimeters. We could convert between different units. And the unit we're using is the standard deviation. So let's say all of these are measured in feet. So this is 16 feet, this is 7 feet, and the mean is 10 feet. So these two are separated by 6 feet, and these two are separated by -3 feet. Okay, so instead of measuring in individual feet, I think there should be, no, maybe that's one too many lines, but don't worry, that's fine. And 987. So instead of measuring in individual feet, we can measure in this guy, number of standard deviations. So the 16 is 2 standard deviations above average. And so the z-score is equal to the number of standard deviations. The number of standard deviations a value is from the mean. From the mean of the set, which is the center of the set. So if we take that x value of 16 and convert it to z-scores, we would say the z value is equal to 2, because it's exactly 2 of these standard deviations up from the mean. And if we convert that 7 to a z-score, well, the z-score would be a -1, because it's exactly 1 standard deviation below the mean. Okay, so that's our z-score. It's nothing more than another unit of measurement. So, and it's actually the standard unit of measurement in statistics, because we could take any data from any set measured in any units and convert that data into z-scores. Okay, so I'm going to erase this. This was just a little side work to sort of explain the z-score. I want to talk about giraffes and sharks. So let's start off with a little bit of information about each. Let's say the average height of an adult giraffe is 16.3 feet. Now, I looked this up on the internet. Now, depending on what site you use or what source you use, you may get different values. But for the sake of this problem, let's just say the information I found online was somewhat accurate. So the mean height or the average height of an adult female giraffe is 16.3 feet, and the standard deviation is 3.3 feet. And I also looked up the great white shark, which has a mean length of 15.6 feet and a standard deviation of 4.8 feet. 4.8. And these are measured in feet. Okay, so this is just the average of the species with their standard deviations. Now, let's say you are maybe on a safari and you see a giraffe out in the wild and it's a lot larger than average. Let's say the giraffe you see is 23 feet tall. So this particular giraffe is 23 feet tall. And you finish up your safari, you get on a boat, and you go swimming in the ocean. And while swimming, you come across a great white shark that is larger than average. And let's say the great white shark that you encounter is 24 feet long. Okay. So X is 24 feet. All right, so the question is, between that 23-foot tall giraffe and that 24-foot long great white shark, which one of those two things is more unusual to see? Which is more statistically unusual, or which one has a lower probability of occurring? Well, let's look at just the raw numbers. We'll look at the feet. So if we look at the difference between 24 feet and the average of 15.6 feet, well, that shark is 8.4 feet above average. Above average. And if we look at that giraffe that's 23 feet tall, and look at the difference between that and the average. So how much taller than average is this giraffe? So we subtract off the 16.3. And that giraffe is 6.7 feet above average. Well, so now we have a shark that's 8.4 feet above average and a giraffe that's 6.7 feet above average. Well, we can't compare these two numbers because they're coming from different sets with different variations and different spreads. So we can't say, well, the shark is more than the distance above average for the shark is more than the distance above average for the giraffe, 8.4 versus 6.7, but we can't compare those two numbers because they're coming from different sets. What we have to do is convert them to z-scores. The z-score allows us to look at relative differences or relative values, so relative differences between sets or relative values within sets. So our formula for the z-score, this is how we convert an individual x value into a z-score. Now remember, each specific data value has its own z-score. So we look at the difference between the x value and the mean, and divide that by the standard deviation. Right. And this is our formula for converting x values to z-scores. And what we're doing here is when we convert to a z-score, we're taking away the original units and we're converting them into the statistical unit number of standard deviations. So what we want to do is we want to take this number of feet and convert that into number of standard deviations. And we want to take this number of feet and convert it into number of standard deviations. All right, so what we'll do is we'll use this z-score formula to convert the height of that giraffe and the length of that shark into z-scores. And the animal with the larger z-score is further from our average relative to the standard deviation of its set. And so now we could compare the two numbers directly. Okay, so giraffe. We do 21 minus 16.3, which we already have down here, 6.7. Divide that by the standard deviation of the set, which is 3.3. And for the shark, we take the 24, subtract off the 15.6, and divide that by the standard deviation of its set. And if you put that into a calculator, and you'll just trust me on this, or you could pause the video and verify this, but if we convert these to z-scores, we get 2.03 for the giraffe. And we get 1.75 for the great white shark. So there's our z-score for the giraffe, and there's our z-score. Let's put a z here and a z here. So there's within this set, an animal with a height of 23 has a z-score of 2.03. And within this set, an animal with a length of 24 feet has a z-score of 1.5. So there's two things I want to make note of here. One, the giraffe is the giraffe being 23 feet tall is more unusual than the great white shark being 24 feet long. And that's simply because it has a larger z-score. The larger the z-score, the more unusual the event. And we could be more specific here and say a 24-foot great white shark is not unusual from a statistical standpoint. It's not statistically unusual, but a 23-foot tall giraffe is. And the reason being is that if you look at the values of z-scores, the average value will have a z-score of 0 because the z-score is distance from average, distance from mean. So the mean will have a z-score of 0 because the mean is not any distance from itself, if that makes sense. And we define this term unusual. The term unusual. Now we'll define it one way when we're talking about probability in terms of in the context of probability, but in the context of statistics, descriptive statistics, we say an event or a value is unusual if it has a z-score bigger than 2 or smaller than -2. So if you convert to a z-score and you get something in here, something within 2 standard deviations of the mean, these are ordinary values. But if you have a z-score outside of that range, so bigger than +2 or smaller than -2, these values, x values that have these z-scores in red, these are unusual values. Right, so the giraffe is falling in this range, is slightly bigger than 2, 2.03. So the giraffe is unusual, and the shark is falling in this range, 1.75. So the shark is not considered, the 24 feet is not considered statistically unusual. Okay, so that about does it. It's a very important topic moving forward. So I just wanted to make sure I had one video designated just specifically for this one topic of z-score, and you're going to see that it's going to come into play when we talk about probability and when we talk about inferential statistics. Okay, that's it for now.